Okay, we're looking at section 4.2 in your textbook. This is on page 205. We're solving linear equation using inverse operations. Mark? So as I mentioned yesterday, I like the fact that this textbook actually does list the goal, which is simple. It's to solve equations by working backwards. I think that's pretty reasonable. Michelle delivers paper waste. She has a cost of $8 per trip for gas, and she earns $72.50 for every ton of paper that she delivers. So it says she had a net earnings of $23.90 on her first trip. Can anyone tell me what that means, net earnings? Only Daniel knows what net earnings means. Nicholas?
I think like what you earn after you subtract everything else.
Yes, and what would those other things be?
Like what you have to pay, like for example, gas.
Exactly. So net earnings, what that refers to then is that's your kind of your profit, right, after your expenses. Okay, so when someone says I net $50,000 a year, they would be referring to how much money they make after taxes and all their expenses. Okay, something like that. So it says she nets $23.90 on her first trip. Not a lot of money. Right? She's not doing too well, this girl. Anyways, determine the amount of paper waste Michelle delivered. So we have to come up with a couple variables here. This is an important step. Before you just drive into the equation, you got to tell me what you're going to use for those variables. So if we say let P represent the number of tons of paper, P of course standing for paper, and let E represent the total earnings. So E again, using that for earnings. So we developed this equation here. Our earnings is equal to $72.50, which is the amount we get per ton of paper. So we're going to multiply that times P. Remember, when there's nothing there, you're assuming that there's a multiplication there, right? There's a little multiplication sign there. That can't be seen. And then minus 8, of course, because we have to pay for gas trip. All right, so we had developed this equation. This 23.90 is from where? Yeah? Yeah, it tells us, right? It tells us she made $23.90. So that's my earnings for this particular trip. And we're trying to figure out how much tons of paper she dropped off by making that much money. Okay, so basically we're solving for the value of P. This whole section in the textbook is telling us how we can use reverse operations to solve for that unknown. Most of you guys know this. We know a couple tricks that make this easier. But just for the purpose of this section, I'm going to show the drawn out way, okay, and then I'll show the easier way, or the way you guys might be accustomed to doing already. Okay, so the drawn out way is that we need to isolate P. So in order to do that, we want P to be by itself. So the first step in doing that is to move everything away from P that's not attached to P. In this case, it's the negative 8. So in order to get rid of the negative 8, on either side of an equal sign, if I do the same thing, I don't change the equality, right? We do the same things on the side of a balance, of a scale. As long as we do the same operation, we don't change anything. Okay, that's important. You can't just go ahead and add 8 to this side and not do anything to this side, because now you've changed the entire thing, right? However, if I do something to this side and I do the exact same to this side, like I times both sides by 1,000,000,000, that equation will still be true. Okay, as long as I do the same thing to this side as I do to this side. In this case, I'm choosing to add the value of 8. Why? So that these values of 8 disappear. Okay, that's the reason. So I add 8 on this side. Another way to think of it is that we move it over the equal sign and we make it positive, and then it disappears at the same time. Okay, that's a bit of a shortcut. Daniel?
Would it be the same thing if you move the 23 over to where the 8 is?
No. Because then you're moving the 23 to where the P is. You want P by itself, so you want to move everything away from the P. Josh?
You just get rid of the 8 plus 3 because it's minus 8 and then plus 8, so then you just cross it over so you know it's 0.
Yeah, but the yellow is what I've added. I've done that.
Oh, that's what
Okay,
you
this was the original equation up here. And so you're right, that's what we're doing. We're getting rid of the 8, so it crosses out. Okay, but in order to do that, you need to add 8 to both sides. Okay? And so then we're left with this equation in white. And what I did to find the P by itself is I divide both sides by 72.5. So in this scenario, these don't become 0, they actually become 1. Right? So even though I don't show it there, it's 1P. Okay, so be aware of that. Like, I know people in math kind of have this tendency to want to cross things out. But these crossing out, there's different meaning here. Here, negative 8 plus 8 results in 0. Here 7250 divided by 7250 results in 1. So I don't think crossing out is necessarily eliminating. You know, in that case it's canceling. In this case it's eliminating, right? So you got to be kind of a little bit conscious of that when you start crossing things out. Yeah.
Do we need to show how we add 8 plus 8 to 28 and 90? Do we have to show that step? Or do we just
No. Alright, so that leaves me with 0.44 is equal to 1p. We don't need to put that 1 there, is equal to p. Okay? The shorter way to do it, as I already mentioned, is I'm going to take that negative 8 and move it over. So 23.90 plus 8, it goes right away, equals 72.50p. And then this step is the same. I need to divide both sides. This becomes 7190 equals 72. Divide both sides by 7250. Did you guys do this in grade 8?
Yeah.
Okay. Yeah, so it's a
No.
bit of review. Some guys didn't. So this crosses out now, and p is equal to that same value. Right? That's the way I would do it. Yeah.
So can we just divide 72.50 by 31.90?
No. No. You can't just divide this by this, because if you did that, if you divide 7250 by 3190, that means you have to divide 3190 by 3190. So you'd have 1 on this side is equal to something still attached to the p. The whole goal of this, guys, is to get p by itself. To get that variable by itself. Okay, that's the whole goal. And if something's not attached to the variable, so in this case, if we're looking at this formula, you can see the 4 is not attached. That's the first thing you're going to identify and get rid of. Move that over the equal sign. Now you're left with 2x equals 10 in this case. Now you have to divide because it's multiplied by x. So that's where the idea of reverse operations comes in. If it's multiplied by x, you got to divide. If it's added to x, you got to subtract. You see that? Alright, so let's go over a couple definitions. We did the first example. So inverse operations. I took the summary or the definition in the textbook. I made it quite a bit shorter. It's just to reverse or undo other operations. So when I do this operation plus 8, that's the inverse operation of the subtraction. Right? I'm just doing the opposite to get rid of that 8. When I do this divided by 7250, it's the inverse operation of this multiplication. One that you can't see, but there is a multiplication sign in there. Alright? So that's what inverse operations is. Multiplication is the inverse of division, subtraction is the inverse of addition, and vice versa. Okay? Isolating a term or variable, that's exactly what we're doing. We perform inverse operations to isolate a variable. So here's an example. I have plus positive 3, even though 3 is on the left-hand side, it's still positive 3, even though you don't see a symbol there, so I need to subtract 3. 3 minus 3 is 0. 5, I do the same thing on the right-hand side, minus 3 is 2. And finally, equivalent equations are equations that have the same solution. Alright, so I'll give you an example of an equivalent equation. These two would be equivalent. Okay? And I know that because everything in here has been multiplied by 2, both on the left-hand side and the right-hand side. Okay, so if I were to solve for x, in this case, which I can see is 4, right? It's 10 minus 6. If I solve for x in this equation, it's going to be the same. So I have 2x is equal to 20 minus 12 is 8. X is going to be 4. So these are equivalent equations. Alright, moving on. Example 2, we have negative 2x plus 4. This is where a lot of people start to get messed up. This negative sign, when it's attached to the variable. For some reason it gave you guys a lot of trouble on the last test. I'll show you how to deal with it right now. So we have plus 4. You're going to move that 4 to the other side, becomes negative 4. Or in other words, you're subtracting 4 from both sides. So these 4's cross out, and you're left with negative 4 on this side, so that becomes 10. This negative sign, don't panic, don't try and move it over to the other side to make it positive, don't worry about it. You're going to address it at the end. How do we do that? We just divide by whatever is in front of the variable. In this case, it's -2. That's fine. I'll divide everything by -2. Okay? Negative number divided by a negative number is positive, so I end up with just positive. And of course, there's a 1x there. Okay? -2 divided by -2 is 1. And then if I divide by -2 on this side, well, I have to divide by -2 on this side. So I get -5. Any questions? All right, example 3. -13, so I'm going to add 13 to both sides. So that 13 crosses out. Again, this is the long way. I'm showing extra steps. I would very much encourage you guys, as I've done so already, to get comfortable with this idea of moving this value away from the W over the equal sign. It changes to a positive. And you don't got to worry about this extra step of adding 13 over here. Okay? Finally, you're left with W over 3 is equal to 20. Some of you guys are doing like this. Sorry, when we had 3190 over equals 72.50p. I've seen some of you guys on your tests, you'll do this. 3190 divided by 72.50 is equal to 72.50p divided by 72.50. Now you laugh, I've seen this on a few people's tests, okay? It's not wrong, it's right, but this gets very confusing very quickly, especially as we increase the complexity of the algebraic expressions. Okay? Get in the habit of using this symbol for division. Okay? Over top. Because it gives you a much better visual. Especially this, like just looking at that, it's not as simple as looking at this, seeing that that is 1. Okay? So if you are doing this, you probably got taught that in grade 8. Get comfortable with learning that division is over top. Okay? It's the same thing as like saying 3x. This is, you could say 3 times x. It's going to make your life, more confusing and more work. Right? You'd rather just say 3x. Even though it's 3 times x, we all know that. Okay? Same idea with x plus 5. Now you're not writing 1x plus 5. You're just writing x. Okay? Michael.
I was just taught in grade 8 to just send it over, so is that fine? Like, it would be written like 31.90 divided by 72.50, and then that equals p.
Yeah,
Yeah?
is that fine?
No. Stop doing this. Right? That's what I'm getting at. If you want to do it like that, just show it like this. This is what I would do. Okay? That's the last example. Thank you. That's it.